All right, so looking at Pythagorean theorem. So this only applies to right angles. So right angles are made with two legs and the hypotenuse. And note they are connected. There is a right angle in the connecting the two legs. Okay, so the Pythagorean theorem states that in order to find the hypotenuse, you can find that by taking your a squared plus b squared equals c squared. A being one leg, b being your second leg, and then c being your hypotenuse. Okay, so that's the formula. On any right angle, this will work. Any right triangle, this will work. Okay, so how this looks is you just take you're going to square the length of side A, the length of side B, add them together, and then take the square root of that, and that will give you C. Okay, so right here, A squared plus B squared equals C squared. Well, we know that A here is 3 inches, B is 4. So we can just take 3 squared plus 4 squared. So 3 squared is 9, 4 squared is 16. 9 plus 16 is going to give us 25. So 25 equals C squared. So the last step to undo a square is square root. Okay, to isolate C, find the square root of both sides. So the square root of 25 is also going to be what C equals. So when you do that, the square root of 25 is 5. So when you multiply 5 times 5, you get 25. So the square root is just what number you multiply by itself to get the number under the square root. Okay. All right, so that's the formula. You're taking one side squaring it plus the other side squaring it and setting it equal to your hypotenuse squared. Your hypotenuse, once again, is the longest length of the triangle. Okay, here's a couple that just are common that we can use. So if you have a side that's 3 and 4, just like what we saw here, it's going to be 25. These come out to a nice whole number. So 5 and 12, that's always going to equal, your C length is always going to be 13. Okay, and then 8 and 15, that's going to give you 17. Okay, those are just quick ones that you're like, oh, I've got a side that's 3 and a side that's 4. Okay, I know the hypotenuse has to be 5. Or likewise with 5 and 12, okay, I know my hypotenuse should be 13, and so on. All right, here we've got a couple more. We're going to go examples. We're just going to go over. So here we want to find the length of the hypotenuse. So we've got a leg that's 7. Okay, so we'll use as our A. So A squared plus B squared equals C squared. All right, so 7 squared is going to give us 14. Nope, sorry, not 14. 49. And that's a common mistake. I see people will multiply those instead of square them, just like I did there for a second. So 49 plus 9 squared is 81. It's going to equal C squared. So 49 plus 81, that's going to give us 130. It's off by 10. It's going to equal C squared. Okay, so now to find what C equals, we have to take the square root. So the square root of 130 is equal to the square root of C squared. The square root of C squared is just going to be C. And then the square root of 130 is going to be 10 point. Because I know 10 times, whoops, not. Nope, it's going to be 11 point. Oops. Because 11 times 11 is 121. So I know it's greater than 11, but it's less than 12. So we're going to get into the decimals here. And on these, I'm only going to take it as far as one place, the tenths place. I don't need to go much further than that for these calculation reasons. So always read the instructions on what place value you're supposed to round to. But in my case here, I'm just asking the students to go to the tenths place. So 11.4 equals C. Okay, so I just went to the tenths place. 11.4 equals C. So side C is 11.4 in whatever units this is measured in. All right, one more. So we've got our A side is 2. Our B side is 7. So we're going to take A squared plus B squared equals C squared. Okay, 2 squared is going to be 4. 7 squared is going to be 49. That is going to equal C squared. So 4 plus 49 is going to give us 53, which is going to equal C squared. Once again, the last step, we take the square root of both sides because we want to know what just C equals. Okay, and the square root of any number squared is just that number. So C equals, and this is going to be 7 point. Once again, 53 is in between 49, which is 7 squared, and 8 squared is 64. So it's 7 point, and I'm just going to round once again to just 2. 7.2 equals C. Okay, so that's using the Pythagorean theorem. That's all you're doing. You're taking the square root of one side. Sorry, not the square root. You're taking the one side squared plus the other side squared, adding it together, and then taking the square root, and that will give you the length of the hypotenuse. Okay, now we can use this same equation and solve for a different variable. So this one's solved for C. We can use it and solve it for whatever side we're missing and use that to solve for a missing side length. But we always have to have at least 2 side lengths known before we can find the third. Okay, so looking at this one, that's exactly what they did here. So we know side, let's see, they're saying this is side A, and we know the hypotenuse, so we know C. So we're now trying to find B. So A squared plus B squared equals C squared. We know that 6 squared plus B squared equals 10 squared. So 6 squared is 36. 10 squared is 100. So we now know, so we want to isolate the variable. So it's the same steps whenever solving a two-step equation. We want to get rid of any number that is a constant that we're adding or subtracting to the variable that we're trying to isolate. So in this case, we want to get rid of 36, so we minus 36. When we minus it here, we have to minus it over here. So on both sides of the equal sign, we have to subtract 36. It cancels out here, leaving us with just b squared. And then on this side here, 100 minus 36 gives us 64. Okay, when we take the square root of b squared is just going to give us b. And then the square root of 64 gives us a. Therefore, b equals 8. So we used it to find the missing side that was not the hypotenuse. So you just rework the equation. And so you could say anytime you're solving for the missing side, so if you're solving for A, then it would be, and what we did here, so this is A squared, this is C squared. So let me write it for B first. So C squared minus A squared equals B squared. Okay, so this is exactly what happened here, but this would just be the formula, so you don't have to go, oh yeah, I gotta solve this minus, this is just showing you've already done those steps, so you know it's whatever C squared is minus your A squared equals B squared. Now if you know B, it's going to be the same except you're just switching the A squared and the B squared. c squared minus b squared is going to equal a squared. So that's all we're doing here, okay? So find the length of leg x in a right triangle if its other leg is 7 inches long and the hypotenuse is 11 inches long, okay? So once again, they use the equation here. We have x squared plus b squared equals c squared. X is the unknown length. Okay, so we put in the known numbers, the known dimensions for b and our c. Go through the steps. X squared plus 49, which is 7 squared, equals 11 squared, which is 121. So once again, you subtract the 49 from both sides. It's going to cancel out on the on the left-hand side. On the right-hand side, you're going to have 121 minus 49, which leaves you with 72. Okay, so x squared is 72. To find out what x is, we have to take the square root of both sides. And here x equals, they just left it as the square root of 72. Because here they wanted the exact equation. If you were to take the square root of 72, once again, 72 is in between 64 and 81. And I'm going to say it's pretty close to being right in the middle. So I'd say if you were given an answer, this would have been 8.5, fairly close to that. Let's just see real quick how close I was. So 8.48, which you'd round up to 8.5. Okay. So here they just want it in that form. So like if they want an exact form, square root of 72 would be your exact form. All right, so that is how we use the Pythagorean theorem to find an unknown side of a right triangle. So once again, it has to be a right triangle. Otherwise, this formula does not work. So any acute triangle or an obtuse triangle, you cannot use this formula.